The mode, median, mean, range, and standard deviation give us numerical information about the distribution of a dataset. Specifically, the mode, median, and mean are measures of center or central tendency, and the range and standard deviation are measures of spread. We will look at how we can determine the measures of center first. So suppose I took a random sample of 9 people and measured their heights. Now the mode of a dataset refers to the data value that is most frequently observed. Notice how the number 154 appears 3 times in this dataset. This means that the mode of this dataset is equal to 154. Now the median refers to the data value that is positioned in the middle of an ordered dataset. Students often forget that to find the median, your data must be first put into order. We usually order the dataset from smallest to largest. We can clearly see that the number 154 is in the middle of the dataset because there are 4 data points above it and there are 4 data points below it. So the median of this dataset is equal to 154. When a dataset is extremely large, it might be helpful for us to use the formula n plus 1 divided by 2. This formula tells us the position of the median. N refers to the total number of data values in our sample. We have a total of 9 values in our sample, so n is equal to 9, and 9 plus 1 is equal to 10, and 10 divided by 2 gives us 5. As a result, the median is equal to the value in the 5th position, which is equal to 154. Note that we could have counted from the bottom and we would still get the same answer as long as the dataset is ordered. We always use the formula n plus 1 divided by 2 to find the position of the median. When we have an odd amount of data values, the median will always be apparent. However, if n is an even number, we see that we have 2 middle data points, and if we use the formula, we end up with 5.5. We see that there isn't a value in this position, so what we do is we take the arithmetic average of the 2 values beside this position, so we would have 154 plus 155 divided by 2, and we get an answer of 154.5. This value is in fact the value of the median for this dataset. The last measure of central tendency we will talk about is the mean. The mean is just another name for the arithmetic average. The formula of the mean is as follows. It is equal to the summation of all data values divided by the total number of data values. If our mean comes from a sample, we call it x bar. So to get the mean for this sample, we add up all the data values, and since there is a total of 10 values, we will divide by 10. As a result, we get a mean or x bar of 165.6. Let's quickly compare between the median and the mean. Both of these are measures of center, but they measure center in a different way. The median refers to the physical middle point, so for this dataset, the median would be equal to 12. Now the mean can be thought of as the balance point. If you calculate the mean for this dataset, you would get a value of 10. If these people were of equal weights, this is the position in which a seesaw would be balanced. Now let's talk about the measures of spread. This includes the range and standard deviation. Both of these values measure spread in a different way. The range is simply the maximum minus the minimum, so it tells us how much room a distribution takes. In this dataset, the range is equal to the largest number, which is 196, minus the smallest number, which is 139. As a result, the range is equal to 57. Now the standard deviation is computed using this formula. The formula looks a little complicated, but the calculation for the standard deviation is simple. We will calculate the standard deviation for the following dataset. I will create a table to help me with my calculations, and this table corresponds to the numerator of the formula. Notice how x bar is contained within the formula, so we should calculate this first. You should find that the mean is equal to 15.4. The formula says we need to subtract each value from x bar, so we do this on the table. 10 minus 15.4 is negative 5.4. 12 minus 15.4 is negative 3.4. 16 minus 15.4 is 0.6, and so on. The next step is to square what we have just calculated. Negative 5.4 squared is 29.16. Negative 3.4 squared is 11.56, and so on. The next step is to find the sum of what we have just calculated. You should find that this is equal to 75.2. Remember that we used this table to calculate the numerator of the formula, so we can now replace it with 75.2. From here, the formula should be pretty straightforward. N refers to the total number of data values, and there are 5 data values in this dataset, so N is equal to 5. We can simplify this, and we end up with a standard deviation that is equal to 4.336. Now what does the standard deviation even tell us? The standard deviation tells us how close the values in a dataset are to the mean. For example, a small standard deviation indicates a small amount of variability for a given dataset. In other words, there will be a lot of values that are closer to the mean, which makes the distribution less spread out. In contrast, a high standard deviation indicates a high amount of variability for a given dataset. In other words, there will be a lot more values that are farther from the mean, which makes the distribution more spread out. The last thing we will talk about is variance. Variance is closely related to the standard deviation. The only difference between these two formulas is that the standard deviation involves taking the square root of the calculations, and for the variance, we don't take the square root. Also, notice how for the standard deviation, we denote it as s, and for the variance, we denote it as s squared. Both of these can be referred to as the sample variance and the sample standard deviation.